Hello, Geometry Honors. Well, today we're going to continue our exploration of circle relationships. And today it's 10.5, apply other angle relationships in circles. And yeah, it talks about how we've talked about how the measure of an inscribed angle is half of the measure of its intercepted arc. We've covered that previously. But what's interesting is that this is true even if one of the sides of the inscribed angles is a tangent line. So what we've got drawn here is we've got a tangent line, which would actually, continue through if it was a line. And then we've got what is actually a secant. And what's formed there is a sort of a type of inscribed angle in a way. So theorem 10.11 says if a tangent and a chord, so we're just going to focus on the chord formed by that secant there, so from edge to edge. If a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is half the measure of the intercepted arcs. Of its intercepted arc. So in our example here, we'll take a look. We've got, let's label the picture a little bit better. Let's say that this intersection point of this secant and tangent, or this chord and tangent. The intersection here is A. We'll call B that end of that chord. We'll put a C on the outside. And we can also think of this is angle 1 that's formed. And then you also have this bigger angle here, angle 2, that's formed. So the measure of angle 2 is going to be half the measure of the major arc BCA. So whatever the measure of BCA is, this angle 2 here formed by the tangent and the chord is going to be half as much. Similarly, the measure of angle 1 is going to be half the measure of arc AB. So it's the same situation as when we have had inscribed angles and the intercepted arcs, but now the inscribed angle looks a little funny because part of the angle is a tangent, which is kind of strange. So in example 1, we've got a tangent and they want us to find x or y. So yep, we got our tangent, we got a chord. Well, the angle formed here is going to be half as much as that big arc there. So we can pretty quickly get that x is 114 degrees. And then y is the measure of this major arc going around here. And because it's the arc, we're going to double the angle, the inscribed angle, so to speak. We're going to double it, and y is going to be 236 degrees. All right, theorem 10.12 is titled Angles Inside the Circle Theorem. And I really don't want to write out too many words for this, so I'm going to draw a picture. And what we've got is we've got chords intersecting in here. So chord BD and chord AC. And what's kind of interesting here is that if you label some angles inside here, you're going to find out an interesting relationship between those angle measures and the arcs. And for the measure of angle 1, I think you guys would agree that once you know one of these angles, you can easily find the other because they're going to be supplementary. But if you're just finding one without any other, if you're finding one without the knowledge of the other measure, how you can find it is by looking at the arcs. Measure of angle 1 is going to be half the sum of measure of arc DC and the measure of arc AB. It's half the sum of that and that. 1/2 of it will be the measure of angle 1. Also, if you know, by vertical angles, it's going to be the same over here, the same measure. Similarly, if you're looking at the measure of angle 2, it's going to be half the measure of arc AD added to the measure of arc BC. And an alternative relationship that we can have here is this picture here. I'll go ahead and draw the picture up here. In this situation, we're going to be looking at an angle outside of a circle, okay? So if you've got an angle formed on the outside of the circle, it could be formed by two tangents, and we've talked about that before, that the measures on the outside would be equal, but this will be a slightly different. We're not going to be talking about the lengths of segments. We're going to be talking about the measure of angles. So we'll draw a secant, and let's draw a tangent right here. And we'll call it angle 1. And we've got an A, a B, and a tangent point right here of C. So I'm about to tell you a relationship between angle 1 and the measures of these arcs that are intercepted by the angle, by the rays of the angle. And it's kind of interesting because when you had angles formed inside the circle, you would add the arcs and cut them in half, kind of find the average of the arcs. But if the angle's on the outside, it's a little bit different. The measure of angle 1 would be equal to 1/2 still, but it's not going to be the sum. It's going to be the difference of the angles. It's going to be the measure of BC minus the measure of AC. So it's a different sort of relationship right there than what we learned before. And the easiest way I think of it is if the angle's on the outside, you're going to subtract the arc measures. If the angle's on the inside, you're going to add them. But they both have the 1/2 aspect of it. So I'm going to go ahead and write out the words. It's a little bit wordy, but maybe this will help some of you to make sense of it. So if a tangent and a secant two tangents or two secants intersect outside a circle. So do you see how it can be any really type of angles as long as it's touching the circle in some way? If the angle is formed on the outside of a circle, then the measure of the angle formed is 1/2 the difference of the intercepted arcs. Pretty wordy, huh? But basically it boils down to the fact that if you have an angle formed on the outside by rays that are somehow interacting with the circle, the measure of it is going to be half the difference of the measures of these arcs, these intercepted arcs. And be smart about it, because an angle is going to need to be positive, so you're always going to do bigger minus the smaller one. Okay, so let's flip this over and put some of this to use. So on the angle here, it's on the inside. So if the angle is formed on the inside, it's going to be half the sum of the arcs. And we're going to get 76 for the measure of that one. Out on the next one, oh, I'm sorry, I was cutting that off a little bit. On the next one, the angle is formed on the outside. So that's going to be half the difference of the intercepted arcs. And x is 18 degrees. Example 3, for each of the following, line T is tangent to the circle. Find the values of x and y. Well, we learned that if you've got a tangent and a chord, then this intercepted arc here is double the angle measure. So x is going to be 115 degrees. We're back to looking at an angle on the inside. When it's the inside, we want to remember that it's half the sums of the angles. And on C, we've got a few things going on here. We've got an exterior angle that's 27. Well, to get that measure of 27, since it's on the outside, it would have been half the difference of the intercepted arcs. So that's 135 minus x. And then we have an equation to solve. I'd probably multiply 2 to both sides to get rid of that 1/2. Subtract the 135 over, divide by a negative, you'll get x is equal to 81. And then if x is equal to 81, I know that's kind of hard to see there, but if x is equal to 81, y is the inscribed angle that intercepts that arc of 81, so the measure of y is half as much, 40.5. And we piece that puzzle together. And then on this last one, angle y is on the outside. It's going to be equal to 1/2. Since it's outside, it's going to be the difference. So really be thinking about if the angle is outside or inside the circle or on the circle. That's going to help you to know whether it's going to be a sum or a difference or half as much. They're all half as much, I suppose. But yeah, if the angle's inside, you're going to have to do a sum and then take half of it. If the angle's on the outside, you're going to have to take a difference and do half of it. And if the angle happens to be right on the circle, it's just going to be half of the intercepted arc, like on A right there. If you'd like some practice, it's page 683, numbers 3. Oh, my rubber bands are breaking. 3 through 31 odds. Thanks for watching.